Okay, so the derivative of a constant times a function is a constant times the derivative of a function. So just review. The derivative of the integral or the antiderivative of a constant times a function is a constant times the antiderivative of a function. The derivative of two functions being added together, or the derivative of each functions added together. The antiderivative of each function is the antiderivative of each function being added together. The derivative of c times x is just c. The antiderivative of c dx is cx plus some constant d. You notice that one is the opposite of the other? What one does, the other one undoes? Yes? The derivative of x to the n is mx to the n minus 1. The antiderivative of x to the n plus 1 over n plus 1 plus some constant c. The derivative of u to the n is n u to the n minus 1 times u prime. The antiderivative of u to the n is, this one's a little bit screwy. It doesn't quite work with this, but it's just u to the n plus 1 over u to the I don't know why we put that one there in the notes. I'll have to check with her to see why she put that one there. The antiderivative of sine u, the derivative of sine u is cos u. The antiderivative of cos is no, sine. Yeah. Derivative of cos is negative sine. Oops, I'm being bad. Cos u times u prime. Sine u times u prime. The antiderivative of sine is negative cos. The derivative of tan is secant squared. The antiderivative of secant squared. Tan. The derivative of cotan. Negative cosecant squared. So the antiderivative of negative, I'm going to tell you it. The antiderivative of cosecant squared is negative cotan. Yeah. Secant is secant u tan u times u prime. The what is it? Cosecant u cotan u, u prime. CSC, let's see if I can write this one. CSCu times cotan u times u prime. The antiderivative of cosecant u, cotan u, d. Anyways. If you remember the derivatives, is it hard to remember the antiderivatives? So I'm not really asking you to memorize twice as much stuff. I'm really only asking you to memorize one set of things and recognize that it goes the other way as well. Oh, I can ask the integral of tan. You just need to do it a different way. Didn't you talk about the integral of tan? No, you probably haven't yet. Yeah. What does the du really mean? You guys talked about that on Friday with Mr. Howell. What does du really mean? Didn't it have to do with changing of variables to make the antiderivative easier? Did you guys notice that? It was to change oops. So it was to change something that was really hard into something that was not really hard. What are you going to let u equal? X squared plus 5. So u equals x squared plus 5. Now, I heard Mr. Howell did it two different ways, his way and the way I do it. So the next thing I ask kids to do is write du over dx equals 2x, take the derivative. Then I ask kids to go, hey, cool! If I take that dx over to the other side, which seems really kind of strange, but just do it, du equals 2x dx, and then you go hunt them. Look, 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 this is right. Yeah. Yes? So the antiderivative becomes, the stuff in the black box comes out and becomes du, the stuff in the yellow box comes out and becomes u cubed. Yeah, so now you take the antiderivative. So it's u to the 4 over 4 plus c. What does du really mean? How much x is changing, actually. It's how much u is changing. Actually, that would be a good way of explaining it. It's how much u is changing. But all it is changing it into a formula that is easier to work with. Right? I'm getting these blank stares. What? It's all good? It's okay? Give me spring break to think about it? Okay, so putting your formulas into action. When do you need u to refining your use of du? Okay, so part of the problem or part of the thing when it comes to antiderivatives is like, what do you do when, right? You're looking at this and you're going, well, you know, if I let u equal x to the 4, then du is going to be 4x cubed. Yes? And then you go looking, do you see any 4x cubed? Do you see anything with even an x cubed in it? So that's probably a bad choice for you. So that's just stupid. And then you go, okay, well, let's u equal x squared minus 2x plus 3. Wow, that's exciting. So then if u is that, then du is 2x. Shoot, there's no 2x. Okay, well, that's just dumb. Okay, so maybe we should try something else. Okay, so what if oh, there's a monomial denominator. Oh, okay, so I could do this. Yeah, I know. I don't actually do this out loud when I'm doing questions. But I'm trying to get you to see my way of thinking around the question. I like u substitution. It changes really ugly antiderivatives into really clean-looking antiderivatives quite quickly. So try to use it first, but it's not always the best way to. Isn't always the best way to go. So you go, okay, there's a monomial denominator. That's cool. I can split it up. So then you can take the antiderivative of 1 over x squared. And you can take the antiderivative of 2 over x cubed. And you can take the antiderivative of 3 over x to the 4th. And these are three really, I'm going to put the word quotes around the word easy, but really easy antiderivatives. Yeah? Relatively easy. I don't look at those and write the antiderivatives. I get all grade first year university on them, and I look at it and I write it like this. I guess it's grade 10. Grade 9, grade 10. switching it to negative exponents so I can do the antiderivative of that. So the antiderivative of negative x, x to the negative 2 is? Add 1, negative 1, divide by negative 1. Add 1, negative 2, divide by negative 2. Add 1, negative 3, divide by negative 3, plus c. Okay, now what? Yeah, finished. So you should write it as negative 1 over x plus 1 over x squared minus 1 over x cubed plus c, and you're finished. So did we need to use u there? No. Okay. X cubed plus 1 all to the 6th power x squared dx. What do you want to try and let u be? Stuff in the brackets. Yay! U equals x cubed plus 1. Nice cubed. X cubed plus 1. Why are you smiling? When you take the derivative, what do you get? 3x squared. Now, the 3 doesn't bother us so much. It's the x squared that gives us a smile on our face. Because now, I don't know how much, I have to look at Mr. Howell's notes to see how he writes it, but I would write it like this. I would say, cool, there's an x squared dx there, so I'm going to leave the x squared there. I'll bring the du and the 3 over, and I'll write the x squared dx like that. He would write it as du equals, or dx equals. Do you like that? Do you like what I'm doing? It is the same. I'm taking this out and bringing this in. And for the other one, I'm taking this out and putting that in. So the antiderivative becomes u to the 6 times du over 3. Perfect. And then you take the antiderivative of just u to the 6. Perfect. Always pull constants out. Always. Pardon me? Fine. Fine. So take the antiderivative of that. It becomes 1/3 times 1/7 u to the 7th plus c. Got scribble all over the mark because I wrote way too big for the first one. Dummy. Okay, now what? Yeah. So your final answer is 1 over 21, open a bracket. What is it? 3x squared. No, it wasn't. It was x cubed. Plus what? 1 to the 7th power plus c. We good? Okay. Well, what are you going to let u equal here? U equals 3x squared. So du over dx equals 6x. And then you go, hey, Mr. F, I don't see a 6 there. That's stupid. So you could write it as du over 6 equals x dx. So the x dx comes out the du over 6 comes in, the 3x squared comes out, which is the scary part, and the u comes in. So it becomes the antiderivative of sine u times 5 times du over 6. So what can you do with that? Bring the 5/6 out, and you take the antiderivative. Antiderivative of sine is negative cos. That was the one that I always screwed up. No, okay. You mean, how do we know? You mean to go from here to here? Yeah, du tells you the variable. Yeah. But it's actually doing, it's not really doing that, but for us, our intents purposes right now, it's telling you the variable is u. Because I'll have v's, r's, p's, t's, and I'll have a du at the end, and you'll go, oh, p's, r's, v's, and t's, those are all constants, take them up front. For all intents purposes right now, it's telling you the variable is u. Later on, it's not quite that easy. It's a little bit, it's saying area's length times width is actually what it's saying. But we need to go back and talk about chapter 5 before we do that. Okay, so you look at the next one and you go, wow, let's u equal x. Well, that's cool, because then you'll get cos u to the 4th sine u du. And you look at it and go, hey, wait just a second, it's the same thing. Right? So what I would suggest you do is to remember some good old-fashioned math 12 bracket action here, cos x to the 4th power sine x dx. So what are you going to let u be here? Yes, u equals cos x du over dx equals derivative of cos negative sine. And then you look at it and you go, but Mr. App, there's no negative there. Do you care? Bring it over to the other side. Negative du equals sine x dx. And your antiderivative should change from something that is not nice to something that is nice. Okay, that's always, always, always what should happen at the next step. If that does not happen, you have screwed it up. Okay? U to the 4th times negative times negative du. So you take the negative out front. What? Yeah, I'm just not skipping steps. And the antiderivative of u to the 4th is negative u to the 5 over 5 plus c. Switch it back. What is u? Cos. Negative bracket cos x to the 5th bracket over 5 plus c. And we're happy. If you're happy and you know it, clap your hands. Oh, there are gazillions that you have. Yeah. They don't fit these patterns. So there are what's the best way of explaining it? There's just undoing the power rule, and then there's undoing trigonometry, and then there's using what we're just learning right now is called U substitution or substitution rule. Then there's something called integration by parts, and then there's something called integration by partial fractions, and then there's something called trig substitution, which is just weird. Yeah, there's about 5 different ways of undoing these things. And then if you really get stuck, you flip to the back of your textbook where there's just formulas that you look up these rules. Hey, it looks like this one, I'll use this rule. Yeah, well, okay, these are all set up to work, so I'm not going to give you a question that you can't do. That's just mean. Where? No, we just did them all. Oh yeah, there were some that weren't working. Yeah, they were because they were trying to show you. The idea there was to get you to see that, oh crap, this pattern has to work for U substitution. You don't just get to use it. If this pattern doesn't work, then you don't get to use it. Okay. You don't like teaching through non-examples, huh? I thought it was pretty cool myself. Okay, what are you going to let U equal? No. Yeah. du over dx is 4. Hey, Mr. Epp, I don't see a 4 out front anywhere, so let's just write it as du over 4 equals dx. So the antiderivative becomes the integral of secant squared u times du over 4, which becomes 1/4 secant squared u du. What's the antiderivative of secant squared? Tan. One-fourth tan u plus c, so becomes 1/4 How's that? We good? Seeing how that's working? Mr. Epp, this is regurgitating from Friday. Okay, what are you going to let u equal? U equals 1 plus 2y squared. So du over dx equals 4y. Oh, you're an idiot, Mr. App. It's not du over dx, it's du over dy. Dummy. I see a y, I don't see a 4. Oh, well, okay, change it around. Make the 4 go over du over 4 equals y dy. So, u, the square root of u times du over 4 equals, now what? Bring the 1 over 4 out, u to the half. So add 1, 3 over 2, divide by the result, 3 over 2 plus c. Now what? Yeah, and make it look reasonably presentable. So you're going to rate it as 2/12 bracket 1 plus 2y squared to the 3/2 plus c. 2/12 is still not acceptable, but anyways. You can write it as 1/6. Did I do that fraction change too quick? No? Flipped and multiplied in my head. Yoink. What are you going to let u equal? Du over dx equals 3x squared. So du over 3 equals, whew. Yeah. So it becomes 1 over 3 u to the 5th du 1 over 3 times 1 over 6 times u to the 6 plus c 1 over 18 x cubed minus 2 to the 6th power. Now, you guys do know how to check and make sure that you're doing this right, huh? Take the derivative of this. You should get what you have for your original question. If you have time, that's a good strategy. Take all your antiderivatives, finish the test, go back and just take the derivatives, each of them, and make sure that it's working. Right? Reverse substitution. Now for some problems that you had in your home. So we're going to let you reverse. U divided by U? I'm looking at this going, what? This are. I have to think about these ones. Okay, what do you think we're going to let U equal? Very sneaky reverse substitution technique. No, that's not a... No. Well, you could do this, but this wouldn't help. Don't write this down. I'm just thinking out loud. That doesn't help you, though. Reverse substitution technique. I wonder what she means by this. Yeah. No. 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 That's the same thing. You know, we're going to stop right here. I have to think about what she means by this. Because this isn't something that I would try to do. No, it'll work. I just have to figure out what we have to do. I think we have to use something like a... Oh, I know what we have to... You're not going to like that. Well, what if we do this? Let's just play. Let's just play. Nah, that doesn't help. No, because it needs to be like this. Yeah, no, that's not going to work. Okay, so what I want you working on right now is dig out some homework. I'll answer some questions. We'll stop this.